Hi, I'm Jim Steele from CSIRO's Australian eHealth Research Centre. This is an overview of our Ontoserver FHIR terminology server product. So we have a range of products and services in the space of clinical terminology. Ontoserver is our world-leading clinical terminology server. It implements the FHIR terminology services and supports syndication-based content distribution. OntoCloak is a new product that we have that is an authorization server that allows you to control access to Ontoserver and the resources that it contains, and also to other related services. Atomio is a standalone syndication service that helps with the managing and distribution of terminology content. We also have a range of front-end tools that I won't cover in depth in this talk. So Snapper is our web-based app for authoring terminology resources. So Snapper Author is specifically for authoring the FHIR terminology resources and publishing them to a FHIR terminology server. And Snapper Map is another version of Snapper that is particularly focused on authoring maps. For example, for mapping legacy terminology to standards-based terminologies. Shrimp is a very widely used tool for browsing SNOMED CT, LOINC, and other FHIR code systems. Again, that's a web-based app that can be pointed at any terminology server, including Ontoserver. We also have a set of open source terminology transforms that allow you to transform code systems that are distributed in non-FHIR formats into FHIR code systems. So for example, OWL ontologies or CLAML classifications. And finally, Pathling is our advanced FHIR analytics server that enables you to build powerful terminology-aware query and queries over FHIR data, and to transform those into forms that you can then use for downstream analytics and reporting. So terminology is important because it's the basis of shared meaning between different systems. When you look at things like FHIR structure definitions or other information model resources, those constitute the branches of clinical data that we're exchanging, but terminology is the fruit where the meaning really lies. Terminology is also a very important part of defining profiles when you are building those information models. So being able to restrict which codes can be used in which parts of your information model is really important. In a large integrated system, having a single reference for terminology is really valuable. It means that the different parts of your systems are using the same versions of terminologies, they're using the same code systems, the same maps, the same value sets, and they're not going to get confused between them. And separating out terminology into an external server really simplifies the process of updating that terminology when there are updates or changes, for example, to versions of the different code systems that are in use. So some of the use cases that we're supporting with our terminology products, data entry is an important one. This is where a user needs to quickly find the right code or codes to record in a specific context, using methods like drop-downs or more importantly, things like type ahead code selection. Validation, when we receive codes, we want to be able to make sure that those codes come from the lists that we deem acceptable for the context in which we're receiving them. For display and understanding, if we've got a set of codes, we want to be able to see what the relationships are between those codes and to explore the details of those codes, if they have properties or synonyms, for example. Mapping allows us to incorporate non-standard terminologies by mapping them across to standard terminologies, also to map between different code sets for different purposes. So for example, mapping clinical codes up to administrative codes, or mapping legacy codes across to the codes that they've been replaced by. Analytics is really important with coded data, so being able to arrange the coded data into categories so that we can develop some understanding of what the data is telling us. And finally, authoring, we very frequently need to make our own code systems or value sets or concept maps, whether that's for building profiles of the information structures that we expect to be using, or defining categories that we're using for analytics, or representing proprietary code systems that might be in use in a specific part of our health system that we may need to map across to standard coding systems. So the big picture of the FHIR terminology resources that we use in our FHIR terminology products, the code system is some set of concepts that have some coherent meaning. They have a bunch of metadata like URL and version and name and title and so on. And then each of the concepts in the code system can have a code, display text, synonyms, and different properties that they support. We can then build code lists by selecting a bunch of codes from one or more code systems to create a value set. This can be done either by bringing in or excluding specific codes, or using rules that, for example, say that all descendants of a certain code should be included or excluded, or all codes that satisfy some particular constraint should be included or excluded. And finally, a concept map is a way of mapping from a set of concepts in one value set to concepts in another value set. And in doing so, defining what the relationship is that holds between those concepts. So whether the concepts are equivalent, or whether one is broader than the other, or that there's just some unspecified relationship between the two for use cases like mapping to billing codes, for example. So these three resources are the core of our Ontoserver FHIR terminology product. So code system, value set, and concept map. We support all the common metadata for those resources as well. So if you post valid FHIR resources of these types to Ontoserver, then it is able to store and process those. We also support the major operations on those resources. So the expand operation, which we can use to search for codes within a value set, or to retrieve the list of all codes in a value set. Validate code that we can use to test whether a given code is a member of a value set. Lookup that we can use to retrieve the information about a given code within a code system. Translate, which is how we use a concept map to take a code and determine what code or codes it maps across to according to a concept map. Closure and subsumes, which are operations that allow us to query the hierarchy that exists in a code system to see which codes are descendants or ancestors of other codes. And then batch operations, which allow us to send through a whole bunch of these operations in a single batch and get a single response based on executing all of those operations. So Ontoserver as a product is designed to be a turnkey high performance implementation of HL7 FHIR's terminology service, which covers all three of those resources and those operations I've just listed. It has full native support for FHIR code systems. So for the search, create, read, update, and delete interactions, as well as for all of those operations I've listed, so that you can upload any FHIR code system in either JSON or XML. And once you've done that, you can use those operations, including filters that might be defined on code systems or properties that are defined on those code systems. We also have deep support for SNOMED CT and LOINC code systems. Those are very complex code systems to deal with very complex distribution formats. So Ontoserver allows you to use those distribution formats natively without having to manually map them across to a FHIR representation. And once you've done that, then those code systems are available for use inside Ontoserver with all of the operations. Ontoserver is designed for the data entry use case. This is particularly demanding because it requires fast implementation of the value set expand operation, and particularly the value set expand operation with a filter, which is how we search for code. So this is designed to support type ahead entry of code, so that the user can start typing a prefix. And Ontoserver has a matching algorithm in its expand implementation, which allows the user to see the best matches for the code that they're typing ahead trying to find. And that matching algorithm is based on a term prefix any order heuristic, which we've found through experimentation and have published in the literature as the best heuristic for satisfying type ahead search for codes in a clinical context. We also support general purpose FHIR validation. So any FHIR resource that you send through to Ontoserver, Ontoserver is able to validate whether that resource is conformant with the profile that resource specifies, including, most importantly, the binding to terminology resources. So where elements of those resources have been associated with some FHIR value set, then Ontoserver can test whether those codes that are on that specific resource you've sent through correspond to those value sets that are defined for that resource type. So some of the specific features that we support for SNOMED CT, we have very deep and long-standing support for SNOMED CT. One of the particularly impressive parts of Ontoserver's implementation is that we have a full implementation of the SNOMED expression constraint language. This includes cardinality constraints and concrete domains, which are used in things like the Australian medicines terminology. So this allows you to build very expressive queries over SNOMED concepts when you're defining value sets to bring in all drugs that have a certain ingredients and a certain dose form, for example, with a strength over a certain amount, or procedures with certain finding sites. And to combine these to build up very, very powerful constraints for identifying the concepts of interest. Ontoserver supports all of the SNOMED CT implicit value sets. So those value sets based on hierarchy, based on ECL constraints, based on SNOMED CT reference sets, and the list of all known reference sets. So this allows you to use these value sets without having to explicitly define them in the FHIR server. They just exist as a URL pattern. Ontoserver also supports the SNOMED CT implicit concept maps. So these are the historical associations concept maps that are included in SNOMED CT distributions, as well as being able to be configured for any SNOMED CT simple map that you would like to expose as an implicit concept map. Ontoserver manages the complexity of the RF2 distribution and multiple version support, so you never have to worry about the format of the RF2 distribution files. Ontoserver will handle all that for you, including snapshot calculation, and it also has an integrated classifier for supporting SNOMED CT's post-coordination syntax, so that you can test the hierarchical relationships between two post-coordinated expressions, or between post-coordinated expressions and pre-coordinated expressions in the SNOMED CT distribution. And you can build value sets of post-coordinated expression libraries as well. Some of the other advanced features in Ontoserver, so we have full support for implementing the LOINC distribution format as well, including implicit value sets that are defined in LOINC, such as answer lists or multi-actual hierarchy value sets. Ontoserver has multi-version support, so for any code system that you put into Ontoserver, whether it's SNOMED CT or LOINC or a code system defined as a FHIR code system, or in fact value sets or concept maps, Ontoserver is able to resolve the most recent version according to known versioning syntaxes, so that you can have multiple versions of these resources on your server at once, and Ontoserver will sensibly identify the most correct one to use in a given context. We have very deep support for FHIR. So as I mentioned, we support code system properties and filters out of the box. So if you define properties on a code system and then a filter that matches that, then that filter is available for value sets that are including or excluding codes from that code system. We support code system supplements, which were added to the FHIR spec in R4, and a very powerful way of either associating new properties or new synonyms, including language translations, for codes that are defined in some externally defined code system. So code systems that are published elsewhere, but you need to localize them for particular contextual use, then code system supplements can be used to do that, and Ontoserver supports those. And we have several algorithmic concept maps as well, what we call the automap concept maps, and these are support automating the mapping of proprietary terms that you've received or proprietary display text across to a FHIR code system based on lexical matching to its display terms and synonyms and codes. Ontoserver also has a really useful syndication model for sharing content between different Ontoservers. And this allows to really build up an ecosystem of servers. So to allow a high-level server to publish content and have it be pulled down by downstream servers in a way that still allows those downstream servers to preserve autonomy. So they're still controlling the content, but they can point up to one or more upstream servers that are providing either value sets or mappings or local code systems, and to be able to pull those down into that local server when they're ready to do that. And this allows for models such as national release centers for standardized coding systems, or top level corporate servers that can be used by different departments within that organization, or health service level servers that can then be used to serve content down to local area servers that also add in code systems or value sets that might be specific to a local area. So all of these can be supported by this syndication model, and that syndication model is also based on standards using the Atom standard from IETF. The syndication model that we have also supports disconnected operation, so it's not a requirement that the upstream server always be available. The downstream server can simply fetch data from the upstream server whenever it's ready to do so. Ontoserver can be part of a more sophisticated architecture in its deployment as well. So this is an architecture diagram describing the deployment of a national server in Australia's National Clinical Terminology Service that Ontoserver is the core of. So it can include a number of terminology servers sitting behind a load balancer. Ontoserver supports HTTP native caching, so that can be used to improve performance for GET requests, which are very commonly used for things like type ahead interaction. It can support the addition of a portal or something like Snapper as an authoring tool, or Shrimp as a browsing tool that can be included in part of an architecture for a terminology service that's operating at either a national level or a top of organization level, for example. We have a range of reference implementations where Ontoserver is being used around the world. So we have over 75 licensees globally. Many of those are using it to support the advanced use of SNOMED CT, or the use of standard value sets or concept maps that they're using within their organization or between organizations. Our Shrimp browser, which is backed by Ontoserver, is in use worldwide. We have commercial licenses for users in Australia, New Zealand, Switzerland, Germany, England, Wales, with evaluation licenses in use in the US, in the ASEAN region, and in South America. The Australian National Clinical Terminology Service was established in 2016 as a one-stop shop for delivering Australian national terminology resources. It now has 1,400 registered users, incorporating state government and health providers, software vendors, universities, companies that do analytics of health data, and many others. And Ontoserver is at the core of that NCTS system. We engaged in a 2-year proof of concept project with NHS Digital in the UK, and recently Ontoserver has been selected as the NHS's national terminology server. We also have a proof of concept project in progress with the NHS Wales Informatics Service. We are in use by the HIMED Consortium of University Hospitals in Germany, by a range of software vendors across New Zealand and UK, including electronic medical record systems, and by clinical colleges in both Australia and Switzerland who use Ontoserver for tracking the procedures that practitioners are performing, and then doing analytics on those records to determine the qualification of those practitioners. So from a technical point of view, Ontoserver is deployed as a pair of Docker containers. So the Ontoserver container itself, and then a Postgres database container. It's also frequently stood up with an HTTP caching proxy in front of it. That can be something as simple as Nginx. We provide a sample Docker Compose file as a place to get started with standing up Ontoserver. But in more advanced deployments, it can also be used with things like Docker Swarm or Kubernetes to manage the choreography of containers. It's out of the box. It's set up to support syndication with the Australian National Clinical Terminology Service, and it can be configured for syndication with any other servers. Ontoserver itself can also behave as a syndication server, or we can use our Atomio product, which I'll cover in a moment. It easily can be run as either a production server supporting live requests, or for staging or dev purposes, or for build purposes if you're using it just to extract code lists for incorporation in a product elsewhere. It can be run either locally or on the cloud. So we have clients who run it in Amazon Web Services or Microsoft Azure, for example. And we have a public GitHub repository which documents some of the deployment models that can be supported for things like using an HTTP caching proxy, establishing TLS at the front end, or read-only horizontal scaling model as well. So there are a bunch of different deployment models that can be used with Ontoserver. It can be run as a simple single production instance. Often this can be accompanied by throwaway staging or indexing instances if you want to do verification of the content before you stand it up in production, or if you want a separate bigger machine that you use in a transient way to build indexes for code systems like SNOMED CT. It has support for smart-based authentication, so using OAuth 2. If you're connecting to remote servers for syndication, it also supports basic authentication to pull down that content. It has role-based access control, including anonymous read-only mode, and that extends also to the individual resource level. So we can use FHIR security tags to define permissions on individual terminology resources, and then use OAuth 2 tokens to authenticate and authorize users to access those resources. As I said, it supports standard HTTP-based caching. So this can support tools like Nginx or Apache as a front-end cache. It uses structured logging. So this supports the use of technologies like ELK or Splunk or Sumo for analyzing the logs that come out of Ontoserver, either for performance or for other health diagnosis reasons. It has a fairly small footprint, so for a very simple deployment, it can be run with 2 CPUs and about 4 gig of RAM is quite sufficient for low usage scenarios. As I said, it does support horizontal scaling. Typically, this is behind a load balancer, and this can be done for either scalability reasons or availability reasons in case one of the nodes goes down, for example, with problems with a cloud provider. Or for blue-green deployment if you're trying to manage a zero uptime scenario. We have a model available publicly on GitHub describing how to do this using Docker Swarm. It's by far the only means of, it's not the only means of doing so, but it's one way of doing it. That's based on a read-only access. Some of the interactions are stateful, so that particular deployment model works by directing all of the stateful interactions, such as the closure operation, to a single node, and all other interactions can be load balanced across the swarm. As I mentioned, we have a security model based on the SMART standard that's used within FHIR, which in turn is based on the OAuth 2 standard, that allows for role-based access control to different terminology resources. We now have a model for per resource read-write permissions, so that each resource can have its access managed. to specific groups of users. We support structured logging, as I mentioned, and we have some reporting APIs for monitoring the aggregated activity that the server is seeing. So one of the new products that we have that can sit alongside Ontoserver is Atomio. So Atomio is a standalone syndication server that you can use to serve feeds of terminology content to downstream servers, whether those are Ontoservers or other clients that consume that content. This simplifies the management of these feeds as a source of truth. It allows you to do things like manage particular collections of content as a versioned release. It supports multiple independent feeds for that purpose, and it has REST-based APIs for adding and removing entries from these feeds. And that Atomio product also respects the per resource security model that is used by Ontoserver. So when Ontoserver publishes, when Ontoserver is going to consume data from a feed, the Ontoserver downstream must have credentials that correspond to the security tags that are on the entries inside Atomio. For managing those authorizations, we now have a product called OntoCloak. So OntoCloak is an extension of the open source KeyCloak product to support the authorizations that are necessary for per resource authorization with Ontoserver and Atomio. OntoCloak provides a dedicated UI for managing the communities that have access to content and which users are members of those communities and what permissions those users have. As I said, it's built on KeyCloak, which is an open source project from Red Hat, and it can be used to integrate with external identity providers via OpenID or SAML, or users can be defined inside KeyCloak as well. So some of the additional front-end tools that we also offer. So we have a user interface demo tool that we've built in collaboration with SNOMED International. This is an exemplar of some of the ways that user interaction can be supported by the FHIR Terminology Services API, including by a server like Ontoserver. So the default server for this demo at snomed.org/UI is SNOMED International's own server, but there's a drop down that allows you to also see how it behaves with the Ontoserver testbed server that we have available. Shrimp is our terminology server browser. It's our terminology browser, pardon me, that uses Ontoserver as a backend. So it allows you to browse the hierarchy and different properties of code systems, including complicated code systems like SNOMED CT and LOINC. Snapper is our web-based authoring tool. It supports both authoring of the code system, value set, and concept map resources, as well as a specific interface for an accelerated view of developing maps between different code sets. So that's all. If you have any questions, then please send them through over email or contact us via the Ontoserver Slack server. Thank you very much.